Okay, so hello everyone, welcome to the Dandelion Mathematics series. In today's video will be about the concept of the arithmetic sequence. And this will be our first video in this topic, and I plan to do maybe about like 3 to 4 videos in this topic. So this will be our first lesson. Okay, and to start off with, I'm going to introduce to you guys the idea of a sequence. So what is a sequence? And the concept of sequence is really simple and easy. So you just have to choose a series of random numbers, you put them together, you line them up, and that will form a sequence. So let's give you an example. So maybe 2, 9, 11, and then maybe 24, and maybe 1,000. So when I put these 5 numbers together, they form a sequence, and all of these numbers, they can be random. You can just randomly pick those numbers and you put them together in a line, and then that will form a sequence. So it's really nothing surprising, and it's really not very fun here. So if we're going to do something fun here, then we're going to form a sequence, and maybe we can find some patterns in here. So what do I mean by patterns? So let's have a sequence that is very simple and classic. So like 1, 2, 3, 4, and 5. And it might go on and on and on. Okay, so what pattern can we find here? So maybe you will notice that between consecutive terms, they have the same difference. So from 1 to 2, the difference is 1. 2 to 3, the difference is 1. 3 to 4, that will be 1. 4 to 5 is still 1. So they have a common difference. A common difference. What I mean by common difference is that between every consecutive terms, they have the same difference. And the word consecutive just means that the terms that they are next to each other. So 1 and 2, they're consecutive. 2 and 3 consecutive, then they are next to each other. And 3 and 4 and 4 and 5. Okay, so that's one example here, and let's take another one. So let's say a sequence that is 2 and 4 and 6 and 8 and 10. So in this sequence, and of course this sequence might go forever. So in this sequence, what pattern do you notice? So what I notice is that it's the same pattern that we just found in our previous example, that between consecutive terms, they have the same difference, which is called a common difference. So from 2 to 4, that will be a difference of 2. 4 to 6 is 2. 6 to 8 is 2. And 8 to 10 is still 2. So they have the common difference between consecutive terms. And this is what is called an arithmetic sequence. So an arithmetic sequence, just means that a sequence that have a common difference. And the idea here is very simple. Okay, so in our previous 2 examples, our common difference, they are all greater than 0. And remember that a common difference can also be negative. And what do I mean by the common difference of a negative value? So let's take an example here that 81, 74, 81 and 74, and then 67 and 60. And it goes on and on and on. Okay, so here, the common difference here is negative, and that is because we can see that from 81 to 74, we are decreasing. Our values are decreasing. So that will make a difference of a negative value. So here we can see that it's negative 7. And from 74 to 67, that will also be a common difference of negative 7. And also same value here, and it goes on and on and on. Okay, so this will be our arithmetic sequence. That it just means that between consecutive terms, they have the same difference. Okay, and then I'm going to show you another thing, and it's a really small and simple thing. Is that let's say that we have three terms in a sequence A, B, and C. Really simple and classic. A, B, and C. Okay, and they are an arithmetic sequence, which means that they have the same difference between consecutive values. And then what I'm going to say here is that 2b equals to a plus c. This will be a thing that you might want to remember because it might be useful in your exams. What does this mean? It just means that the b as the midterm, the term in the middle, all right? The term in the middle here. The b equals to, if you rearrange this equation, so b equals to a plus c over 2. What does this mean? It just means that the value of b equals to the average value of a and c. So a plus c over 2 is just taking the average value of a and c. So the summary here is that the midterm equals to the average value of the two value next to it. Yes, and we can actually prove this very easily. So we just have to rewrite this. Okay, so we have our A, B, and C. The same thing as before. A, B, and C. Okay, so A is just A. And how about B? It's like we know that A and B, they have a difference of D, right? So instead of just writing B, let's write it in another form. Let's write it in A plus D, right? A plus D. And in this case, D can be positive or negative, it doesn't matter. And then for C, so between B and C, they also have a difference of D. So it means that from the base of B, we're going to add another D. So A plus D is B, and then we're going to add another D, which makes C to be equals to A plus 2D. Nice and easy. Okay, so let's try to prove the thing that we just wrote here. Okay, so 2b, that will be 2 times a plus d. And then equals to a plus c. What is a? A is just a. What is c? C is a plus 2d. And from observations, we can see that the two sides, they balance out, which means that they match to each other. So this equation is valid. So just remember that the midterm b, the midterm equals to the average value of the two values around it. Okay, then what we're going to do, we are going to, oh no, wait. Before we do the thing that I'm just going to talk about, let's give you an example. So let's say 3 and then b. And then let's say 7. Okay, so what is the value of b? And it's just nice and simple. B equals to a plus c over 2. And we know the value of a and c is just the value next to b, which is 3 and 7. So b equals to 3 plus 7 over 2, and that's just 5. Okay, so b equals to 5. And remember that this property, it only happens when your sequence is the arithmetic sequence, which means that the difference between consecutive terms, they are the same. So 2 to 5 is a 2. 5 to 7 is a 2. They have the same difference. Okay, what we're going to do next is that we're going to introduce our first formula included in this topic, the arithmetic sequence. And let's actually derive this formula. Okay, so let's take an example that let's say that now I have an arithmetic sequence called AN, and it has a common difference of D. Okay, and let's write this sequence out. So A1, then A2, A3, A4, A5, and blah, 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 and then AN. Okay, So what we're trying to do here is that we are trying to express an in another form. So instead of just writing an, we're writing it in another form. And how are we going to do that? So what are we going to do here is that we're going to try to find a pattern here. So let's see that. Okay, so A1 is just A1, nothing surprising. And then A2, let's write A2 in another form. We know that the common difference is D. So let's write A2 in A1 plus D, just as what we did before. Okay, then A3, we plus another D. So that will be A1 plus 2D. A4, we plus another D. A1 plus 3D. A5, that will be A1 plus 4D. And it goes on and on and on until we reach AN. Okay, let's find the pattern here. What is our pattern? So, well, what is the pattern here? So A1 is just A1. A2 is A1 plus 1D. A3 is A1 plus 2D. A4 is A1 plus 3D. A5 is A1 plus 4D. So what do you notice? You might notice some special relationship between the number of term and the coefficient of a common difference here. Yes, and that's what we are going to do here. Second term, term 2, term number 2. The coefficient of D is 1. The third term, term number 3, coefficient 2. Term number 4, coefficient 3. Term number 5, coefficient 4. What do we notice? The coefficient of the common difference is always 1 less than what term, the number of term that we are in right now. So A1 always exists. It doesn't change. What is changing is the coefficient of our common difference. So yes. So here, let's just write out A1, because A1 is always there, plus, so what are we plussing here? So as we said, the coefficient of the common difference is always 1 less than the term. So that will be n minus 1, since we're in the nth term here, n minus 1 times the common difference d. So that will be our first formula that we're going to know in the arithmetic sequence, and this is a really, really important one. When you're doing any practice problems or tests or exams, almost every single arithmetic sequence problem, you are going to use this formula, so you better know how you got it. And so just try to memorize it. Okay, so what are we going to do now? Wait, hold on. My Apple Pencil doesn't work. Okay, now it worked. Okay, let's give you a practice example here. Okay, so let's say a sequence, an arithmetic sequence, 8, 5, 2, -1, and it goes on and on and on. And now let's try to find what is its formula of AN. Okay, so we know that AN equals to A1 plus n minus 1 times its common difference in the sequence. So 3 things we're going to know here. The n and the A1 and the D. So since n is just a general thing, so we don't have to care about it here. So what we're going to find is only 2 things, A1 and D. We're going to find out what is A1 and what is D. And A1 obviously is just the first term in our sequence. So in this case, it's 8. And the common difference D. What is D? So now let's try to find D. So from 8 to 5, we decrease by 3. From 5 to 2, decrease by 3. 2 to -1, decrease by 3. So obviously, then our common difference is going to be -3. Okay, so what is AN now? The AN is 8 plus n minus 1 times -3. And do have a good habit here. When you are writing a negative value here, write a bracket here. Okay, then rearranging this, we're going to get -3n plus 11, and that will be our general formula for this sequence here. this is the general formula of finding any term in this sequence. And let's try to verify whether our formula, like our equation that we just got, is correct or not. So let's say that we're going to find the fourth term. So a4. What is a4? So negative 3 times 4, and then plus 11, and that will be negative 12 plus 11, that will be negative 1. And let's see, first term, second, third, and fourth. So this is what we're trying to find here, and that's negative 1. That's what we got. So yay, we got it correct. And that's all we're going to cover in this video. So we're just going to introduce our concepts and our first formula. And in the next video, I'm going to introduce you the formula of how to find the sum of the sequence here. Yes, so that's all from Dandelion today. And if you have any question, please comment down below. And if you would like to stay in tune for further videos, please click subscribe. And I will see you next time.